The circle above has a center O and has a circumference of 36. What is the length of the minor arc, AC? Well, here's what we can do. You know the circumference is the distance around. So the entire circumference is 36. This arc is intercepted by this right angle. So that right angle is 90 degrees of the 360 degrees in a circle. So I'm going to set up a proportion. 90 degrees is to 360. I want to know the length of the arc that's 90 degrees if the circumference, the distance around, is 36. You were taught a formula in geometry that said the length of the arc over the circumference, that equals the central angle over 360. And this is kind of what we have going on here. If I would plug that in, the length of the arc, that's going to be what I'm solving for, over the circumference, which is 36. That equals the central angle, which is 90 over 360. So it's kind of just flipped what you're used to seeing. Well, here, since 36 times 10 is 360, here my answer would have to be 9, because 9 times 10 is 90. And you can always go about solving this by cross-multiplying, but here the length of the arc is letter A, 9. Problem number 36, point P is the center of the circle. What is the value of x? Well, here's what I'm going to do. Since point P is the center of the circle, angle x is a central angle. So that means the central angle is equal to the arc it intercepts. So since that angle is x, I know minor arc BC is going to be x. Now, angle BAC, this angle is an inscribed angle, and inscribed angles are half the measure of the arc they intercept. So since this angle also intercepts arc BC, and arc BC is x, then this angle, this inscribed angle, is going to be x divided by 2, because it's half the arc it intercepts. Now, here's what we're going to do. If you take any quadrilateral, any four-sided shape, the sum of the angles of a quadrilateral is going to be 360. Because basically you can break up any quadrilateral into two triangles, and each triangle, the sum of the angles is 180. So basically you're dealing with 2 times 180, or 360. Now this is going to be a rather unusual looking quadrilateral, but if I draw this quadrilateral, the sum of the angles, so this angle A, this little angle, and then this reflex angle. This blue shape is a quadrilateral, and the sum of the interior angles is going to be 360. So if I add up those angles, I have x over 2 plus, well, these two angles are both 20, so plus 20 plus this angle that's on the outside of the x. Well, I know a full circle is 360 degrees, but since I know this part of the angle right here is equal to x, then the opposite side is going to be 360 minus x. Because, for example, let's say this angle in the central here, let's say it was 70 degrees. Well, this angle that's behind it is going to be 360 minus 70, or 290. Well, here, I don't know this angle is 70, I know this angle is x, so the angle behind it is 360 minus x. So I'm going to take the 4 angles of the quadrilateral. I'm going to take x over 2, the 220s, and the 360 minus x, add them up, and say they have to equal 360, because the sum of the angles of a quadrilateral is 360. So here's what I have. I have 20 plus 20 plus 360 is going to be 400. And here I have x over 2. That's the same as 1x over 2, which is the same as 1/2 x. So if I take 1/2 x and I subtract 1x, a half minus 1 is negative a half. So here I have negative 1/2 x plus 400 equals 360. And now I'm going to solve this equation by subtracting 400 on both sides. So I have negative 1/2 x equals negative 40. So if I multiply both sides by negative 2, here x is going to be equal to 80 degrees. So this one here dealt with central angles and inscribed angles, and the sum of the measures of the angles of a quadrilateral is 360. But here our answer is 80 degrees. Problem 19. In the xy plane above, O is the center of a circle, and the measure of angle AOB, that angle, is equal to pi over A radians. And the question says, what is the value of A? Well, you might remember that pi radians equals 180 degrees. And in Algebra 2 and Trig, when you needed to convert from radians to degrees, you would multiply by 180 over pi, or from degrees to radians, you would multiply by pi over 180, because pi radians is the same as 180 degrees. Now what we're going to do is this. We're going to draw a right triangle in our diagram. Since I know the coordinates of A are radical 3 and 1, that means the x value is radical 3 and the y value is 1. So here, starting from point O, the origin, the x value is radical 3, the y value is 1. What I can do now is to try to figure out this angle by going SOHCAHTOA. Here I know the hypotenuse is line segment OA. Here I'm trying to figure out the angle, because they're telling you angle AOB. So here I have the angle, if I can call that x. I know 1 is opposite, and I know radical 3 is adjacent. So here, if I use SOHCAHTOA, because I formed a right triangle, here they're giving you opposite and adjacent, so here this is going to be a tangent question. I know the tangent of an angle equals opposite over adjacent, so the tangent of x equals opposite, which is 1, over adjacent, which is radical 3. So what I'm going to do on my calculator is take the inverse tangent. I'm going to press second tangent and then enter in my fraction 1 over radical 3. So here I did second tangent and then 1 over radical 3, and here my calculator gave me 30 degrees. So I know this angle is 30 degrees. But the question said angle AOB, 30 degrees, is equal to pi over A radians. So what I'm going to do is I'm going to convert 30 degrees into radians by multiplying it by 180 on the denominator and pi in the numerator. So this is the way you convert degrees to radians. You multiply it by pi over 180. So this turns out to be 30 pi over 180, and 30 over 180. 30 goes into 30 once, 30 goes into 180 6 times. So here this is going to be pi over 6. So 30 degrees is pi over 6 radians. Well, since 30 degrees is pi over 6 radians, and the question said that angle is equal to pi over A, in this case here, A is going to be 6. So that one dealt with trigonometry and SOHCAHTOA. Problem 36. In the figure above, point O is the center of the circle, and LM and MN are tangents to the circle at points L and N. And one of the rules from geometry said if you have a radius and you have a tangent drawn to that endpoint, then the radius and the tangent are perpendicular. So those two angles in the diagram are right angles. So here, angle OLM and ONM are right angles. So here's what I have. I have to find the length of minor arc LN. What I'm going to do is I'm going to find the measure of that central angle, O, because that central angle will help us then find the length of that arc. And I have a quadrilateral here, and just like we saw in the last question, the four interior angles of a quadrilateral always have to add up to 360. So I have the 60 degrees by angle M. I have those two 90-degree angles, so 2 times 90 or 180, and then I can figure out what that central angle is if I call it X, because the four angles of that quadrilateral have to add up to 360. So here I have 60 plus 180, or 240 plus X equals 360. So that means if I subtract 240 on both sides, I know that central angle X is going to be 120 degrees. So here, since this central angle is 120 degrees, if I want to find the length of arc LN, well, I can do the length of the arc over the circumference equals the central angle over 360. So here my central angle is 120 over 360. So basically this arc is 120 over 360, or 1/3 the circumference. So I can do the length of the arc, X, over the circumference, which they told us was 96. So X over 96 equals 1/3. So here I can now cross multiply. 3 times X equals 96. Or here X is going to be equal to 32. So that's the length of the arc, 32. Problem 34, in a circle with center O, the central angle AOB is 5 pi over 4 radians. The area of the sector, so this area of that blue shaded region, is what fraction the area of the entire circle. So what I want to do is I want to try to figure out this central angle, because then I can kind of set up a proportion to figure out that fraction. Well, here I know the central angle is 5 pi over 4 radians. And the way you convert radians to degrees is you multiply it by 180 over pi. All these questions with radians can be solved by remembering that pi radians is equal to 180 degrees. So by multiplying by 180 over pi, you're basically multiplying by the same thing over itself, which is just 1. So here, the pi's are going to cancel, and here I'm going to have 5/4 times 180, or 4 goes into 180 45 times, and here 5 times 45, that's going to give you 225 degrees. So basically I could set up this proportion. The central angle over 360, which in this case is equal to 225 over 360, or if I reduce that on my calculator, that turns out to be 0.625, or 5/8. So basically here the question is, what is the fraction of this area, the sector, to the entire area of the circle? Well, that ratio is the same as the ratio of the central angle over 360. So here, this is a grid question. You could have gridded in either 5 fraction 8 or 0.625. In the circle above, AB is a diameter, which means you have 2 semicircles, and it says the length of the arc ADB. So this arc, the length is 8 pi, which means this semicircle, the length of the arc is 8 pi, which means the circumference is equal to 16 pi, because you have 2 semicircles drawn. So here the question says, what is the length of the radius? Well, one of the formulas that is in the beginning of each section of the SAT says that the circumference equals 2 times pi times r. You definitely want to become familiar with the formulas that they give you. Not that you have to go home and memorize the formulas, but know which formulas are given to you. So here, since the circumference is 2 pi r, and I know the circumference is equal to 16 pi, I'm going to set up the equation. 2 pi r equals 16 pi, and I'll divide both sides by 2 pi, which means here the pi's cancel, and 16 over 2 gives you answer choice C, 8. Problem 36 in the figure above. A circle has center O and has a radius of 10. If the length of arc AB, which is shown in bold, is between 5 and 6, what is one possible integer value of x? Well, what I can do is I can use a formula. The length of the arc over the circumference. If I take the length of that red arc divided by the entire circle, that's going to equal the central angle divided by the whole central angle, which is 360. So the length of the arc over the circumference equals the central angle over 360. Well, here they tell me the length of the arc is in between 5 and 6. So I'm going to do this question twice. First, I'll plug in the length of the arc as 5, get an answer for x, the central angle. Then I'll plug in 6 for the length of the arc, get an answer for x, the central angle, because it says what is one possible value of x. So here I have the length of the arc, which is greater than 5, over the circumference, where the circumference equals 2 times pi times r, or 2 times 3.14 times 10, or here the circumference is equal to 62.8. So I have 5 over 62.8. That equals the central angle, which is x, over 360. So here I can cross multiply. 62.8x equals 5 times 360, or 62.8x equals 1800. And here, if I divide both sides by 62.8, I'm going to get x equals 28.66. Now, this is what the central angle was when the length of the arc was 5. It says the length of the arc is in between 5 and 6. So now let me plug in 6 for the length of the arc. So here the length of the arc, 6, over the circumference, which is still 62.8. That equals the central angle, which is what I'm solving for, over 360. Now I'll cross multiply. I have 62.8x. That equals 6 times 360. So here I'm going to have 62.8x. That equals 2160. And here if I divide both sides by 62.8, here I'm going to get x is equal to 34.39. So the question says the length of the arc can be anywhere between 5 and 6. That means the central angle can be anywhere between 28.66 degrees and 34.39 degrees. The question says, what is one possible integer value of x? So in between 28.66 and 34.39, the integers 29, 30, 31, 32, 33, or 34. Any of those 6 answer choices would be correct for this grid question. Points A and B lie on a circle with radius of 1, so I'll label the 2 radii of 1, and the length of arc AB is pi over 3. So this particular arc is pi over 3. What fraction of the circumference is the length of the arc? Well, here they tell you the length of this arc is pi over 3 radians, and if I want to multiply that by 180 over pi to turn that into degrees, a lot of times students find these questions easier to deal with degrees. So here, pi over 3 radians times 180 over pi, that's how you convert radians into degrees, here is equal to 60 degrees. So I have a circle whose radii are 1, they intercept an arc of 60 degrees. They want to know what fraction of the circumference is the length of the arc. So they want to know what fraction of the 60 to the entire arc. Well, 60 is the length of the arc. The entire circle is 360. So here my answer is going to be 60 over 360, or 1/6. You can either enter in the fraction 1/6, or 1 divided by 6 on your calculator is 0.1666 repeating. So you can type in 0.166 or 0.167. Remember, when you deal with these decimals, you don't have to round off. If you round it off, it's correct to 0.167, but you can just simply decimal point and the first 3 numbers that you get of your decimal. So any of these 3 are correct.